Hello everyone, my name is James Lowry, and today I will be discussing how theories of visual attention can be applied into the real world in order to enhance the processing of complex scenes in real world scenarios. So, what exactly is visual attention? Well, visual attention refers to the mental process that allows us to selectively focus on specific information in our environment while ignoring other stimuli. Attention is a very selective process, and so it has a finite capacity. There are different theories as to how attention is selected and distributed, backed up by a variety of research. In 1890, William James was a psychologist who examined what is known as functionalism, which describes the causal relationships between internal states and external behaviors. He said, quote, "Attention is the taking possession by the mind in clear and vivid form of one out of what seem several simultaneously possible objects or trains of thought. Localization, concentration of consciousness are of its essence. It implies withdrawal from some things in order to deal effectively with others, and is a condition which has a real opposite in the confused, dazed, scatterbrained state which in French is called distraction." The allocation of attention is extremely important in everyday life, whether it be trying to find a lost item, listening to a teacher, or maintaining attention in a social setting. Attention is required to be allocated to specific stimuli, while ignoring other information deemed irrelevant to the current circumstances. And this is what is known as selective attention. In 1958, Donald Broadbent was a psychologist who proposed the filter theory of attention. This theory has been integral in the research of attention. The theory states that when information enters the sensory system, it's briefly held in a sensory buffer, which is a short-term store. A selective input then filters through the information based on the situation and its relevance. At an early age, children often fail to filter out tasks and important information, so instead their attention is distributed across important and non-important information. This in turn results in the brain processing more information than required, which leads to a less efficient process system. In 2005, Koch, Sanders, and Neville created a study in which adults and children were instructed to attend one channel while ignoring another. The ignored channel had an oddball probe, and it was found that only children detected the probe on the ignored channel. The development of selective attention improves from infancy through to adolescence, mostly due to educational experiences, conditioning, and general life. In 1964, Anne Treisman proposed the attenuation model. This model theorizes that selective attention does not flat out block irrelevant information, but instead the processing system weakens it. This then allows relevant stimuli to enter a higher threshold of processing. The model suggests that all information is analyzed to some extent, but irrelevant information does not reach the consciousness as strongly. This model is in fact a juxtaposition to Donald Broadbent's theory from 1986, in which he stated that there was a stricter barrier between relevant and irrelevant information and how they are processed. Another model that was created is the zoom lens model. So in 1986, the zoom lens model was proposed by psychologists Charles Erickson and James Dee. This model specifically, in a visual sense, states that visual attention operates similarly to that of a camera lens, where we adjust our focus from sharp details to broader information, unlike Broadbent and William James's more linear theories. The model suggests that as we focus on one stimuli, the surrounding peripheral vision is decreased in clarity, but the surrounding stimuli is still maintained, with attention dynamically changing depending on the circumstances. This model applies Treisman's theory, where all information is processed but just in varying degrees of importance, specifically being applied to visual stimuli. So, how can these models be applied to the real world? Each model discussed have several different real-world applications in order to aid the use of visual attention. William James's theory explains why people focus on meaningful and important stimuli, for example, hearing someone say your name in a crowd. It can also be applied in advertising, using bright colors and engaging content in order to pique the interest of consumers. Broadbent's filter theory can be applied to abilities to drive, filtering out irrelevant information and focusing on critical information such as traffic lights and turn signals. It can also be helped to use to design user interfaces to reduce distractions, so for example on a Tesla car where there's a screen. Treisman's attenuation model can also be applied to environments where a person is required to multitask, so for example an office, so that background information is processed at a lower input. It also explains noticing important cues even when distracted, so for example a fire alarm. Charles Erickson's zoom lens theory can also be applied in driving. It can also be used in sports, so for example in football where the players have to scan the entire pitch when playing in order to gain an advantage. Next, I'm going to move on to the practical applications of visual attention and how medical applications can be created in order to enhance and aid visual attention. The first application I will be analysing is eye tracking. Eye tracking is, specifically in terms of medicine, a valuable medical tool that provides a detailed overview of how visual attention is distributed. In 1908, Edmund Huey created a device which could track eye movement while reading, using a contact lens with a small opening for the pupil which was attached to a pointer which changed directions following the eye. By tracking eye movement, researchers can gain understandings into gaze patterns and fixations. Studies surrounding eye trackers have aided several fields, including computing, neuroscience, and psychology, and there's evidence that suggests that individuals who suffer from psychological disorders exert different patterns in eye movement. In 2019, researchers Philippa Howard, Li Zhang, and Valerie Benson wanted to look at the visual processing differences in individuals with autism. Through the analysis of different studies, they found that there was evidence of a difference in visual processing within individuals with autism. One study in particular in 2023 assessed eye movement in social settings in young children in order to help identify autism at an early age. It was in fact found that eye tracking movement was able to identify children with or without autism fairly accurately. This means that autism can be found much earlier in infancy with the use of eye tracking. Another application is radiology. So, what exactly is radiology? Well, radiology is a variety of medical tools which use imaging technology such as X-rays, CT, MRI, and ultrasounds in order to diagnose, monitor, and treat diseases and injuries. In terms of radiology, visual attention in radiologists is vital because they must have the ability to detect small abnormalities when analyzing images and structures. Through extensive training, education, and general experience, radiologists will be able to naturally develop a higher understanding of their work, with their vision being key in spotting abnormal structures. So how can visual attention exactly be applied to radiology? So with humans naturally using selective attention, this can be used to a radiologist's advantage. A possible application of visual attention could be during training. Radiologists could use different scanning strategies in order to enhance their skills, scanning over certain structures at certain points and abnormalities in different areas. Eye tracking could also be used to show trainees how expert radiologists analyze images. Research in visual attention can also allow improvements in the recognition of abnormalities with repeated exposure. They should also have the ability to manage their workload by taking short breaks and emphasizing pacing in order to reduce fatigue, boredom, and maintain focus. Another field where selective attention, more specifically visual attention, can be applied is in driving. So visual attention is absolutely central to driving, as vision and attention separately are both the only way in which you can detect critical stimuli such as traffic lights or turn signals. Drivers mainly focus on important information such as the road, surrounding cars and nearby pedestrians, while ignoring unimportant stimuli such as billboards or natural scenery. When driving, attention must be equally distributed between the road, wing mirrors and back mirror without losing any situational focus. Focusing too narrowly can cause drivers to miss out potential dangers and hazards. And effective and safe driving is dependent on visual attention, and without it, driving wouldn't be safe. In conclusion, visual attention is a fundamental cognitive process that allows us to select and prioritize information in complex environments. It helps us understand how attention works and can help explain behaviors, diagnose conditions, and educational training. By applying the base principles of visual attention to training and design, we can improve accuracy, safety, and decision making. Ultimately, the concept of visual attention is a bridge between theory and practice, showing that its research can benefit society on a broader scale. Here's my references.